So today we're going to be taking a look at pygame and putting it into use for our Wordle-clone project. And there should be a folder you've got for today's date and tutorial. And inside there should be really 3 useful files that we're going to be putting to use. So you can see there are 2 Python files, one called main, which is open over here, and one called board that's open down here. And then this last guy is a little graphic. It's an 82 by 82 square, and it's set up to basically be the visual container for each of our letters. And it just is that little square right there. So those are the files that are included. And we're going to see how basically these 2 Python files are going to interact. So since we already have the graphic file open, or we know what it looks like, close this guy. And then we're going to really focus on main and board and how we set up the beginning aspects of pygame. So for this first little bit, we're going to focus on the top part of the code here, and then we'll dive into some of the additional components there. Okay, so very first thing we're going to do in this case is import pygame, and that's a module that we're going to be using. It allows us to do a lot of the visual things, makes sound and visuals and sprites and movement and character input and monitoring keyboard events, all that kind of stuff, a thing that we can do more easily than in a standard Python file. So pygame is really designed, in fact, to help make some games. So straight away we'll do that so we can have all that utility available to us. The next thing we'll do here is we're going to import from a file that we've made ourselves called board.py, which is the other Python file you can see here. And that allows us then access to all of the things inside of that code as well. All right. Pygame init is basically initializing all of the stuff that we need for using pygame, and that kind of sets the stage, so to speak, for the visual parts of what we're going to be wanting to display into a screen that we're going to be making. All right, you'll notice on 6 and 7 that we've got the height and width of basically our play screen that we're going to be utilizing. So rather than just hard coding those in later on, they're set up as variables or constants really up here, so that we can set those and then use them in our code down below. But that way, if we ever did need to change them, it would be clear what we were changing, because they're not just mystery numbers. They're the width of 550 and the height of 750 for our display board. Okay. In the next area, this was kind of an attempt to keep track of the various colors that we might need during our Wordle game in one spot. And we've seen this kind of setup before, where a color is designated by its RGB components. So if I have 0 red and 0 green and 0 blue, that then is black. And conversely, if I have everything turned on, so full power green, red, and blue, then I've got white. So all those together make up white. Then this green is the closest I think I've been able to make to the green from the Wordle game. Likewise with the gold. So these aren't just necessarily yellow and full green as normal, but colors that look pretty close to the ones in the original game. Last but not least, there's a gray that gets put to use for when we're getting letters in, and yeah, again, that's a variation. So 120, 120, 120. It's a relatively middle of the road amount of all the colors, which, if they're evenly distributed, comes across as a shade of gray. Okay, and then just for ease of access, if we want to be able to loop through the colors for any reason, I've made this into a list, so we have access to the colors we've just defined up above. Okay, line 16 there is set up to indicate a font that we are going to be using to display some things out onto the play board. And because this is a word-based game, we do need some visual elements that include text. So pygame font is the area that we're going to be looking, and then inside of here I've defined the actual file or the font type that we're going to be accessing, Comic Sans. 60 relates to its size, and then true is not really needed, but it's there if we wanted to be able to use this font in an italics mode. So we could have omitted the true here when setting the font, but that's what it's there for, is to say if we want to try a version of italicized Comic Sans, we can. Alright, the next important player is on line 18, and this variable is being set up, display surface, to contain basically the game board that we're going to be creating. So we've given it a name on the left hand side, display surface, and then we're saying what kind of thing it is. It's going to be a display of type pygame, and by setting the mode I can determine the width and height of the game board. And notice there are double parentheses because it needs these guys enclosed in their own setup as far as height and width go. If I had made that a separate variable, say the board parameters, then they could just be enclosed in one set of parentheses, but since I've got two different variables, they need to go this way. That's what set mode is expecting. Okay, the next thing on line 19 is the caption that we're going to be displaying. So when the game runs, we'll be able to see that. And right, so that's kind of our startup here. Let's kind of take a look now at some of how this is working. So while I'm on the main Python file, I can choose run, and it'll activate the code in idle, and there we have our display. We can see our boxes. So now we want to know what exactly is making all of this stuff happen. So there are a few additional pieces, and those really are relating to the board, and we can see there's a value of 5 and 6 in there. Just so happens that we have 5 boxes in each of our 6 rows. And right below that we can see a display surface fill with 3 values that are all the same. So whenever we see really 3 values for RGB that are all equal, that's a shade of gray, and that accounts for the gray that we have for our background here. And then we're really going to kind of now dive into the board setup itself as far as what's making this happen, because really in the main what we're able to do is simply create a new variable called blank board, reference the board class with a capital B, and then pass it 2 parameters that it needs to set up a board. So this is one aspect that I thought would be really nice for us to take a look at for the first time, to set up a new class in a separate file, and then be able to, with one line of code, create a board based on the specifications that we pass in, and then all of the heavy lifting happens in that other file. So it kind of lets us streamline the look of our code quite a bit. So without belaboring that, let's then go take a look at this guy, which is the board class. And notice that it's set up as with a capital B. That's by convention. Classes that we create, we capitalize so that they stand out in contrast to standard variable names. Okay, and what I've done then is at the start of this class, I've defined several variables that will be used throughout the code. So there's a start X, a box offset, and a start Y. And we can mess with those and kind of see what happens when we do that. But that's those are all being used later in this code to help create the boxes spaced out as they are. Okay. Another big thing to notice here is this function called init, and notice the underscore before and after the word init. This is a special function that is, again, by convention used so that anytime someone creates an instance of our board class, then this code will get called as that board is created. So if I say something equals board, this function is going to be called, and that initializes things for the details of our board. Okay, so kind of going into some depth here, we've got self, which is the thing itself, the object that's been created, and that's pretty standard that you see when you're creating a new object, that you'll pass access to that thing so that it has the control of the item in memory while we're working on it. And the two things that we actually do pass in then are the blocks per row. So in this case, when we called the code here, we passed it two variables, 5 and 6, and those then relate to the blocks per row 5, and the 6 is how many rows we want to have. All right, so for a blank Wordle board, we have a 5x6 grid, and that's what the init function is going to do for us. Okay. Pretty commonly then what you'll see happen is whatever has been passed in to the function to initialize it then gets set as the defining aspects of that actual object, the one we called self in the first line, so that it uses those things throughout the code. So we pass them in from the external variables, and now we're setting those to apply them to the actual object of blank board that we created over in the main code. Okay, so we'll see using self dot several times in this code because that's referring to the actual object self, and then key aspects or properties of that block that we've made. Okay, one thing I don't want to forget about, so I'll mention it now, is any line that I've got indicating or starting with a comment or the pound sign is really there for when this code was being developed and tested. So I've left it so we can uncomment them if we want to and see some details, or if we're making some changes and we want to see if it what's causing any grief or what's working correctly or where something's getting placed. We can uncomment those easily and then run the code again. So in contrast, line 8 is actually an comment that has details about the code, so I'm not going to uncomment that because it's not actually code. And then similarly, other code comments appearing after the lines, such as on 4, 5, and 6, are there for description as opposed to actual code that we can use for testing purposes. So anybody that has the start of the line with a pound sign is there for testing purposes only, but they've been left in so that if we want to put them to use again, we can. Okay, so we talked about the init code being the one that is called whenever an object of this type board is being created, and really the two important things were for a board are how many rows and columns we need. So blocks per row is 5, and then we're going to have 6 rows for our blank board. Okay. Now the next thing that is important here is the draw function, and this is important to put anything onto our game board. And if you notice again, we have a self, so the object that we have created is going to be accessed by the self keyword. Pygame is allowing us access to the various functions that we need to be able to set up the updates for displaying. And the display surface was actually the name of the board that we created. So back over in main, you'll recall we had a display surface that was set up to be basically the game board. So the display, and it had a height and width. Notice that was also the one we set up to have the gray background. Okay, so we're passing that to the draw function, so as we're trying to put the game pieces or the little squares that will contain the letters, we can apply that to the board that we've created, which at this point really just is a gray background. Okay, All right, line 15 is there to identify which graphic we want to use as the outline or the holder for our letters later on, and it's just an 82 by 82 square that happens to be a PNG files. So that's what box is going to be, is a nicely set up square that has a little outline to it, so that we can use it to put our letters in and then add some coloring to them later on. Okay. The next actual line of code that's in action is setting up how many rows we want to have. And because we would like to have these spaced a bit, you'll notice that there's times 100 here. So what that's going to do is help us space things out a bit. So this range is starting at 0, so we'll start at the very left-hand portion of the game board, and then as we loop through, we're going to say however many rows we've got, self.rows, we're going to multiply that by 100. So we had told it that we were going to have 6 rows, so this is saying 0 through 6, and then we're going to go through them, stepping through 100 at a time. Okay, and that really is all about just spacing things out for us. Okay, 18 and 19 are getting the initial X and Y coordinates of our box, the little graphic we're going to put on the screen. So self.startX is the beginning value that we want to have set up for X coordinate, and 10 just makes it so that it's not going to be running up straight into the left-hand side of our game board, so it gives a little bit of space. So again, if we wanted to, we can adjust that 10 so it's more or less. Okay, likewise, Y just helps us step down a little bit. So the Y coordinate, meaning from the upper left-hand corner of the window, drops down 10 pixels, and then we're not going to be stuck at the very top of the game board. So just spacing things out for looks, and very easily then we can adjust these values. Okay, and you'll also notice that part of the Y component is saying, hey, we want to be able to, as we draw a brand new set of 5 boxes each row, we're going to have it drop down because it's going to increase by 100 each time as we loop through. So the very first time, that's actually why we started with 0, is we wanted the 0 plus the beginning to drop us down just 10, but going forward it would drop down 110 or 210 and so on. Okay, all right, and then the next little piece we have here, again, there are several lines commented out that are just there for testing purposes, and that was really to let us see how we could imagine letters looking inside here. So we'll take a look at that in a second, but let me just go through the for loop, and you'll probably get the idea that we're starting to loop through, and we're saying how many blocks per row we want to have, and we want to have that be set to 5 plus 1 because when we use range, it's not including the last number. So we have to actually add the plus 1 so that it actually gets to 5. So 1 through 6, but the 6th, when we use a range in Python, is kind of skipped over. Okay, so that gives us our 5 different boxes. Okay, and then this line 24 is actually putting the graphic onto our display surface. So the game board that we made called display surface, Blit is the thing that says draw this on top of an existing graphic. We're telling it we want to draw the box, which was loaded up with the graphic PNG that we had, this little guy, and then the X and Y are where it's going to be placed on the board. Okay, and then last but not least, we're going to say, hey, when we're done with that particular loop through, we want to update and have the boxes move over by a certain amount. And we've used the variable box offset set it to 112, and that's setting up our spacing then for what's going on when we run the code. So now we can see that when we do run the main, it does indeed set up our boxes. It's got the gray background, and if we ever wanted to mess with those other values, we can easily change things. Okay, so just so that we have a visual of what the letters could look like in here, I'm going to go ahead and reactivate those bits of code, the ones that have to do with our font and our text. So I'll go ahead and reactivate that, and reactivate that. I do need to resave the file once I've changed it, and then I'm going to come back to main and rerun that. And then now we can see those guys are setting up the letter W for us to be able to see relative to our boxes. So this isn't really the portion. We don't really want the board to be in charge of putting the letters in there. We really just want it to make the blank board. But I thought it was useful for testing to kind of get a visual for what that would look like. Probably we're going to also want some control over where exactly these appear in each box, because they're a little bit close to the left edge right now, and there's obviously some space over here. So we'd want to probably mess with that so we can have our letters look good too. But those little guys that I just uncommented are basically putting those letters in that spot. And again, so this is what we're printing, the letter W. We're printing it in black. This is the text that we're going to be using. We're rendering that font to the screen, and that really happens though when we do a display surface blit of the text. And you'll notice that I already did in fact increase the X value by 5, just to make sure that the W was appearing inside that box. So if I were to change that to say 10, save it and rerun it, we would see that the W has moved over a little bit. But again, just as a reminder, we really don't want the board to be in charge of the letters. We want either a separate module to do that, and we'll have to figure out if that's what we want to do, or if we want the main code to be taking care of that. So that's the bulk of what board does for us. And then really the rest of the code back over here in the main is currently designed to be listening for any keyboard input that we have. So go through this a little bit, and you'll probably get the gist of what's happening. So right now the output is saying awaiting user input letter by letter, and so I can start actually typing around the keyboard and see what happens. So let's say I wanted to guess the word about, so I can hit, oops, have to be actively on the game board when I'm doing that. So I'll move this back over here. You can see the output happening. So I hit A, and we see the output generated, event key 97, but the letter is actually the A, and then B, O, U, and let's say I made a mistake and I wanted to go back. I do have it currently set up to take the backspace, so the word at that point would just be A, B, O, and maybe I changed my mind and I want it to be above. Okay, so you can see when it finishes that it did allow us to backspace successfully and keep track of how many characters there were in the word, and then when we were all finished, it noted that the word that we had guessed was above. Okay, so this is still early days, but it's doing a lot of the visual things and accounting for how the player could interact with our game board, as opposed to using Colab and being more text bound than we were before. Okay, so that's a little startup for this code and what it's doing. Once we've got a good handle on this, we can decide if we want to build an additional module for determining how to interact with the letters as they come in, if we want to keep it here, and then when we've decided those things, we can start to fill in the logic that we've already developed, which should be functional in this world for making Wordle happen. So we've done already all the hard lifting for making the game functional. Now we're focusing on making the visuals look good and giving the person an experience probably more what they're used to.